This is a demonstration of doing data annotation in eeglab using the visedmarks and batch context plugins. What I've done is I've created a folder structure and I made it available on GitHub. And this contains all the files that you'll need to actually perform this tutorial. So if you go to GitHub and do a search for eeglab data annotate demo, enter, and then just go to the J Desjardins and then click on the download zip. This should start the download and go to the downloads folder. So I'll be doing this demonstration using Ubuntu 14 and MATLAB 2012B. Everything being developed should be compatible with MATLAB as far back as 2008. And there'll be some small variations, basically just in terms of key presses across Macs and Linux, but nothing too significant. So now the zip file is downloaded. I'm just going to extract it to the folder. And then I'll just delete the zip file. So what we have here is basically a demo project. And this is a typical folder structure of how we do analyses in the labs that I work in. And what we'll see is that in the analysis folder, there are data files, and there's 2 raw demo input files. And these are the ones that we're going to annotate in this tutorial. There's an empty log folder, and this is basically where files that are generated whenever you're batching a procedure go, as well as diaries of the command line of what happens during the execution of the jobs. In the support, there's config files. The config files hold properties for the visual edit interface. So these are basically holding a bunch of properties of how the ggplot scroll window will operate, including a bunch of key assignments for certain functions. Inside the dependencies folder is the eeglab distribution, including the 2 plugins, the visedmarks and the batch context that I'll be using in this demonstration. And then there are scripts. So there are 2 scripts. And really this demonstration revolves around these scripts. One of them is going to perform data annotation, and the second one will select data based on those annotations. And what I can do is just walk through these right now before opening MATLAB. So the batch context plugin will run scripts sequentially. So you pick a script, which is really just a text file containing a bunch of MATLAB functions, and then you select a list of data files to execute that script on. And the way that it works, if you open it in a text editor, is these are really just, typical commands, mostly from the eeglab library. But what we see are there are some key strings. For example, the square bracket and then batch dfn. This is a key string representing the batch data file name. And this is a string that gets swapped in whenever the batch context plugin is actually executing this string. Batch dfn specifically is if I ask to run this script on 10 files, it will create 10 M files and save them into the log folder, where in each one it replaces this with the current file name out of the 10. And then it will then just go ahead and execute all 10 of those M files in sequence. And you can change the output name by using batch dfn, and then in this format you say go to the first from last period and replace everything after that in the batch data file name with underscore an.set. So this is annotation.set. And we'll see specifically what that looks like once we're running the job. And then you can also tell the file to be saved in a specific location, and that is analysis data annotated output files, which is a folder right here. So this script loads a file, And then what it does is it performs a bunch of initiation functions to start a marker. So basically what we're going to be doing is in the scroll plot, in the eeglab window, we're going to be highlighting periods of time as though we have several different highlighting markers. And what I'm doing here is really just defining which markers I have. So I've added a label called type 1, and I've given it this color, red. So these are RGB values. And then type 2 is green, and then type 3, 4, 5, 6. And then I've also added these other three, so thing Q, thing W, and thing E. And then once those marks are initiated, I call the pop viz-ed function, and then turning the pop GUI off, so it won't ask me to adjust the parameters again. It will just open the scroll plot. And then it will call UI wait, so the script will stop here and wait for this figure to close. Once that figure closes, it goes ahead and it saves the output from pop.viz-ed into this new file in a new directory. The second script actually loads the output from the first one, the _an.set, and then it uses this function to select time marks with the labels type 1, 2, and 3. And then once it selects those, it writes those to a specific file called T1 to 3 in a specific output path, which is the types 1 to 3 output files. Once it writes that, it then does a similar thing where it selects the types 4 to 6 and then sends those to a different folder with a different name. Okay. So the details of writing scripts there is very modular, and there's a bunch of different ways of writing them, and there'll be other demonstrations of that. But for now, we can just go ahead and start running these. So I'll start MATLAB. Now we won't need the editor. Now, the first thing that I'm going to do for this to run is I'm going to navigate into the folder that I just extracted. So in my downloads folder here, and then I'm going to direct MATLAB right to the demo project so that I can see analysis. Now, the scripts assume that MATLAB at the top here could see analysis, and then it navigates down from there. So it's very important to point right to demo project. So at the top of this, you see analysis. And then I'll just expand these windows out. The next thing I'm going to do is I'm going to set the path. So I'm just going to set the MATLAB path to the default, and then I'm going to add with subfolders in analysis, support, and then the dependencies. And that's the dependencies that holds all of the eeglab. Close it. I'm not going to bother saving it. Now, in the command line, and this is the case with Ubuntu, I'm not sure if it's the case with other operating systems, the setting the default figure renderer to OpenGL can solve a few problems with the graphical user interface of the scroll plot. And then I'm going to start eeglab. So, to get started, what we want to do is we want to load a bunch of predefined properties of the scroll plot, including a bunch of key assignments for performing functions. And then once we load that configuration, every time that we start the viz-ed figure, it will have all of those properties loaded by default. So to do that, I'm going to go to File and viz-ed configuration, and I'm going to load the viz-ed configuration file. It's an analysis, support, config, and I'm going to use the VE demo CFG. So what we see is these are a bunch of properties of the eeglab window. The select command, extend select, alt select. These have to do with the mouse presses, mouse clicking on the figure window. And the main one is the key select command. So these are functions that will be performed while the eeglab scroll window is open whenever you click on keyboard keys. And what we can do is we can define an entire list of these and we can extend it. So I'm just going to click on this and then maybe zoom into this a bit. So the way that this works is the first character represents the actual key that you would press to perform this function in the scroll plot. So for example, if I press T and there's a comma, it's going to perform VE, eeglab, topoplot, GCBF. So if I press T while the mouse is over the scroll plot, it will plot the topography of the activation at that time. If I press R, it will do the drop P, which is really just refreshing the scroll plot. And then if I press S, it will call the VE edit function, which holds a bunch of different functions to perform with the data, as well as the events and the marks and the channel flagging. S will call the SM option, which is the select mark, and turning it on. This means that I'll be able to click on a highlight by pressing the S button, and then it will become the current WinReg window. If I press D, it will do the RWM, which is remove a WinReg mark. And then rather than naming a mark, it will do the pop select. So a GUI will pop up with a list of all of the marks, and I can choose which one I want to delete. AWM is add a WinReg mark. So if I press number 1, it will add a mark for type 1. The same thing through to 6. If I do shift and 1 and shift and 2, etc., it will perform the APM, and that is the add a page mark. So this will flag the entire page that is open, that's being displayed in the scroll plot window with type 1, and then it will also do the PF, which is page forward on. So if I hit shift 1, that entire window will get flagged for type 1, and then it'll move on to the next window, and I can just go through the data that way. I've also added a few things here. If I press Q, it will do the VE edit, and it'll do thing Q, thing W, thing E. And then I've also added these QEM functions. This is the quick event make. So if I hit the Z key, it will add a new event with the type event Z, same for X and C. Now we can just keep adding to this, and what I'll do is I'll just add one called J, comma, VE edit, and I'm going to add a WinReg mark, and I'm going to call this one junk. There. Now, because in the script the junk mark wasn't defined, whenever I try and add this in the scroll plot, an extra graphical user interface will come up and asking to fill in needed information for that mark. For example, it won't know what color to give that mark until we tell it. So I'll hit OK, and then I'll just zoom back out. Whenever you're using these property grid interfaces, always make sure that you leave any item that you've edited, or else it won't register whenever you hit OK. So other things is you can adjust here the Y spacing. I've set it to 120, as this is basically filtered continuous data. This will give us a good range to see everything. And then the window time length is 20 seconds, so I'll be able to scroll through 20 seconds at a time, marking the data this way. Another thing is the position. So this is defining where the scroll plot will show up by default whenever it opens. And this is the size and position. And I think that's all that we have to edit for this. Whenever you're working with this, just know that whenever you whenever you're on an item, a basic description will show up down at the bottom. So for this, I will hit OK, and that should have updated a global variable. I'm just going to go back in and make sure that the edit is still there. Yep, and it's still there. So we added the J for the junk. Great. So now that we have it set up, that the VE edit or the scroll plot VisEdMarks annotation tool is set up with the properties that we want, what we want to do is we actually want to batch and say, I'm going to perform this, initiate marks, and then bring up the scroll window. I'll do the annotation and then save the file, and then bring up the next file, and I'll do the same thing, save that one. And then once those are done, just automatically separate the data in the two types of marks that we've made. Now to run a batch, go to File and Batch and run a history template batch. And this is the interface used to perform the batching. So the first thing that we need are the history files. These are the scripts, support scripts, and we can select both of them. So it will run sequentially through any number of scripts that you have. The batch configuration is mostly important in terms of if you're submitting jobs to a cluster. This will define how those jobs will execute in a cluster. For these jobs, really all that we have to specify is the execution function. So EF current base means that these scripts will be executed in the current instance of the base MATLAB. And we have two scripts here, but we only need the one configuration because we want them both to run the same way. And then we choose the data files that we want to run these scripts on. And the raw input files, I'll select the two sets. Okay, so that's populated. And then one last thing is down in the context, this is another thing that's mostly important for whenever you're working on a cluster and submitting large compute jobs. This will define where things are located on the cluster and how it'll run. But it also defines where you can specify where you want to put the log file. And the log files contain the actual M files that are generated and executed, as well as the diary of the command line during the execution, and as well as any error files that might occur. So I'm going to send this to analysis log. Again, always leave the item, analysis log. So once everything is set, I'll just click OK. So what's happened is it's loaded the first file, and then it's put the scroll plot where I wanted it to go. So as a bit of a demonstration here, there are sort of the traditional VisEd tools. If I right-click on a channel, it will gray it out. If I shift-click, I have the option of adding an event that I can give it any name I want. I'll just call this one junk. And then it adds an event. Now for the keyboard assignments, there are more functions, and specifically are the time marks. So they're all labeled here, the manual type 1 through 6, and then thing Q and W, etc. Now if I want to add those marks, what I can do is I can select an area with the native WinReg utility, and then if I wanted to add type 1, while I'm over this window, I would just click on the number 1 key, and then that adds an annotation. Now if I wanted to delete part of it, I could select this, and then while I'm on this window, I could click on the D, and then it will ask me which type of mark I want to remove. I'll click type 1, and then it removes that portion of it. If I then wanted to select the period of time that this is on, I would go over this mark and click on S for select, and it highlights it in black. And then if I wanted to delete that, I could just push D again. Now other key assignments, I've assigned a quick key to the event. Z, event X, and event C. And these are just added by pressing the keys. I can also add any of the thing Q, thing W, or thing E. Now for doing more of like sleep type scoring, what I can do is I'll go forward a page and then I'll just press Shift 1, Shift 1 again, Shift 1, Shift 2, Shift 2, Shift 3, Shift 4, Shift 5, Shift 6, 6, 6, 6, Shift 1, 1, 2, 3, 4, 4, 5, 6, 6, 6. Okay, so what I've done is I've just scrolled through the data by clicking Shift and these number keys. And if I now step back and show the entire recording, we can see that the data have been annotated based on what key I was pressing to move forward. So now we can see that as I was moving forward, I pressed 1, 1, 1, 1, 2, and generated these type annotations. And then I can still go in here, and let's say I wanted to then flag this as junk. And then this is where it'll ask me. It doesn't know what color junk is supposed to be. So this graphical user interface comes up, and then I can say, well, I want junk to be this nice brown color. Okay, and that's flagged there. And then I could also flag this one if I wanted. I'll mark this as junk as well. So now let's say I'm happy with the way that everything has been annotated. I can just hit the update the EEG structure. This will update the mark structure inside of EEG, and then once this window closes, it will save the file to the annotated output files, and then it will load the next file that I selected for the batch, and then bring up the new figure window. So I'll just click on that. And then now we can see back here that one of these has been populated, the first data set. And now we're looking at the second data set. So I'm just going to quickly go through and do 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. And I'm just clicking Shift and then values 1 through 6. And then we'll step back from this one. And then we can see that I basically just scored it sequentially. Okay, so for this one, I'm just going to hit the update EEG structure. And then we see that in the annotated output files, now data 2 has been populated. And then once these were done, it moved on to the second script and populated the types 1 to 3 output files in here, as well as the types 4 to 6 output files. And in the log file, what it's done is it's created a date and timestamp file for each of the scripts. So the data annotation, and then we see here is the actual M file that was executed for the first one, as well as the log. So the M file actually contains all of the commands with the actual names entered into them, and then the log file contains the actual text of what would have occurred in the command line while those were executing. So what I'll do now is I'll just load one of the final output files. Clear this, load an existing data set, analysis, data, and then let's look at the first one with the 4 to 6. This. And I'll just plot this. And then I'll change this to show the pretty much the whole recording. was the wrong setting. I want to change the time range. There. So what we can see now is I've loaded the output file that has the types 4 to 6. So these are the times. These are the periods of time in the original data file that I had flagged as either type 4, 5, or 6. And then the period of time where there were marks of 1, 2, or 3 has been removed, and there's now a boundary. But we can also see that all of the other flags have maintained where I had flagged this period for junk. And that's it. That's how to do data annotation in eeglab using the viz marks and batch context tools together.